Good afternoon, students. Good afternoon for the lecture 27 class. So today in this class we are discussing the new unit, that is laminar and turbulent flows in a pipe. So we are discussing unit 3 in the fluid mechanics subject. So in the last classes we have discussed about the kinetic viscosity, the kinetic flows, and the kinematic fluid kinematics, and also the dynamic flows of a fluid in a pipeline by using various formulas like Euler's formula, Bernoulli's formula, and the momentum equation, and also the various applications of the momentum equation with the problems. So now we are in the unit 3, where we are having two types of flows. So in the unit 2 we have discussed about the various types of flows, that you are having 6 types of flows. Now the unit 3 we are discussing closely the two types of flows, that is laminar flow and turbulent flow. And what are the closed contact flows, closed pipe flows, where you are having different formulas given by the scientist, and what are the various types of methods to follow whenever the pipes are in parallel, pipes are in series, and what are the minor losses in the pipe, right? Yes. So these are the main contents to be discussed in this unit 3. It takes around 15 to 20 classes to complete in full length. So here we are having the major topics like laminar flow and turbulent flow irrespective to the Reynolds experiment. So the scientist Reynolds had made an experiment on this laminar and turbulent flows and showed various phenomena and showed various characteristics. Next, the characteristics of laminar and turbulent flows. The next one, the shear and velocity distribution, comma, loss of the fluid friction, and the scientist Huygens-Poiseuille formula. The next topic is flow between the various parallel plates of a water, of a fluid. Flow through long tubes, flow through the tubes, hydrodynamically smooth and rough flows. Hydrodynamically smooth and rough flows. The next concept is closed contact flow. Closed contact flow, in that you are having various equations set by Dachy and Weisbach equation, minor losses in the pipe, pipes in series, what happens to the pipes in parallel. Next, the total energy line and hydraulic gradient line. Next one, variation of friction factor with Reynolds number. Next method is the variation of friction factor with the Reynolds number, said by different scientists like Modi's chart, the pipe network problems, Hazen-Williams formula, and hard cross method. Like this, we are having various types of methods where it is to be discussed with the Reynolds number, along with this pipes in closer contact, right? So like this, we will discuss the unit 3, where mainly we are discussing about the characteristics of laminar flow and turbulent flow, the Reynolds experiment, and also the problems associated with this Reynolds number, and also the laminar and turbulent flow. Okay, yes, we'll switch on to the major content. So if you see in the unit 2, you have discussed about the kinetic viscosity and the dynamic viscosity. There, how the fluid is flowing in the open channels or in the closed channels in the pipe bends by using momentum equation, and also the Euler's formula. Here we are applying the Reynolds experiment. By conducting the Reynolds experiment on turbulent and laminar flows, we'll see what are the characteristics and nature of the water bodies. So if you see the structure, if you see the pipeline structure of any company or industry, see the internal flow through pipes, through elbows, to T-sections, through the valves, etc., as in the oil refinery, are found in nearly every industry. So if you see the example, this is the oil refinery, where the oil is flowing in different channels. You can see a straight pipe, you can see elbow, you can see some of the bends, you can see this is the top, this is a T section, this is a T section, you can see some of the bends in the pipes, T's, right, elbows. So some of the valves where you are having an opening and closing of the water or a liquid or a oil. So there is oil refinery plant where you can see various types of channels having in the pipes. So you can see the T-bend here, you can see the elbows here, right? You can see the different sort of elbows, different pipe diameters, different movement of the oil in this water, in this industry. Now, what are the main objectives? What are the main objectives of this fluid mechanism, this laminar and turbulent flow? So in this unit, we will discuss deeply the concepts of laminar and turbulent flow, how this laminar and turbulent flow are moving in a pipe, and the analysis of fully developed flow. Fully developed flow. Next one is how to calculate the major and minor losses in a pipe with respect to the laminar and turbulent flow in a piping networks, and determining the pumping power requirements, how the pumping power requirements are associated whenever you are using the laminar and turbulent flows in the pipes having major and minor losses. The next one, understand the various velocity and flow rates, measuring techniques, and learn their advantages and disadvantages. So overall, this unit 3 gives the entire concept of how the laminar and turbulent flows are moving in a pipe by using various types of network system, right? So by using this Reynolds number, we are having some problems to discuss as well as the experiments to be conducted on this laminar and turbulent flow. So in this unit also you're having majorly problems and also the derivations, right? Yes, we will go in deeper. So generally if you see the liquids or gases flow through pipes, as I already mentioned in the unit 1, we are discussing about the liquids, the fluids, right? Yes. Okay, some some technical disturbance. Next. So in the liquids or gases flowing through the pipes or ducts is commonly used in heating and cooling applications and the fluid distribution networks. So here what we are discussing means the liquid, it may be the oil, it may be the water, or it may be some other high viscosity liquid or a gas flowing through pipes or ducts or open channels. So generally gases will not go in open channels, only in pipes. Whereas compared to the liquid is flowing in the pipes or ducts is commonly used for what? Cooling or heating, cooling and heating applications. And fluid distribution network. The fluid distribution network means this is a fluid. So how the fluid is distributing to various pipes to various departments. Okay, next. The fluid in such applications is usually forced to flow by a fan or a pump through the flow section. So generally, if we have a gravity, so by using gravity pressure, directly you can use the flow of you can use the pipes, right? So with the gravity concept, the fluid is automatically moving from top section to the bottom section. So if in some cases when the design is complicated, whenever you are using in industry applications, definitely you have to use some sort of mechanical devices, some sort of electromechanical devices, that is a pumps, where the fluid is flowing from one place to other place with some pressure. Next one is the particular attention okay. The next one is the attention of friction, which is directly related to the pressure drop and head loss during the flow through the pipes and ducts. So whenever the fluid is flowing through the pipes, whenever the fluid is flowing through the pipes and ducts, definitely you are having friction occurring at the walls of the pipes, and also the pressure drop from high to low, and also the head loss. So this all happens whenever you are having fluctuations in the water, fluctuations in the pipe, and also the pump specifications. The next one, the pressure drop is then used to determine the pumping power requirement. So when you get the power drops or power fluctuations, whenever you are having changes in the pumping system, right? Whenever there is a friction, whenever there is a pressure drop, whenever there is a head loss, so all we are getting by the means of pumping specifications, as well as the water or a fluid coming from one station to the other station. Now the figure shows here the rectangular channel and a square channel. Here the figure shows the rectangular duct and the square duct. So what's happening here? So here, whenever the water is flowing in the rectangular duct, whenever the water is flowing in the square pipe, so the area is 1.2 atmosphere, here the area is 50 atmosphere. So you can see the pressure differences between the inside and outside without undergoing any significant distortion, but non-circular pipes cannot. So you can see some sort of pressure differences between the inside and outside of the pipe, whereas in the non-circular pipes such as a rectangular duct or in other things, you cannot see the such type of pressure differences. So whenever the pipe is flowing in a square channel, what happens? Rectangular channel. Whenever the fluid is flowing in a circular pipe, what happens? This all depends upon the pumping power requirement and also the design of the channel. Next one. So if you see the theoretical solutions, so if you do any theoretical solutions, these are obtained for a few simple cases such as fully developed laminar flow on a circular pipe. So if you see the laminar pipe flow in a circular pipe, so you will make some theoretical solutions based upon the sample experiments done for the water or a liquid whenever it is flowing only in a circular pipe. Therefore, we must rely on experimental results. So theoretically in this type of cases, whatever the fluid mechanics or some sort of experimental things, so theoretically you will get one type of solution, experimentally you are getting one type of solution. So in some cases we must rely on this experimental results, in some cases we have to rely on theoretical solutions. Therefore, we must rely on experimental results and empirical relations for most fluid flow problems rather than closed form analytical solutions. So manaki, in order to get a solution in any subject, we have to follow some sort of experiments. One is theoretical, one is experimental. In that you are having various types of empirical relations, simulation models, analytical models, right? So like this, you're having various types of things, but you have to choose the optimum things in order to where we are getting proper results. So in this fluid flow problem, generally we go with the experimental results rather than the analytical solutions. Analytical means whatever the solutions we are getting through paper. Now this formula already we have discussed in the previous class, that is m is equals to rho into volume into average velocity into area, average velocity into area of cross section. That implies, so integral of velocity, integral of area, that is with respect to the u that is Reynolds number d into cross section. Now the value of the average velocity, V average at some stream-wise cross section is determined from the requirement that the conservation of mass principle is satisfied. So we have satisfied already this momentum equation. The mass is equals to rho into V into A. Right? Whenever the water is flowing in a, whenever the water is flowing in a pipe with a laminar flow, see, whenever the water is flowing with some velocity, we are having the average velocity how the water is flowing. So whenever it's taking the maximum, depends upon the pressure or force we are applying. So it is having the maximum point at the center line. So that is nothing but a V maximum. So the average velocity is defined as the average speed through the cross section, right? Through the cross section. For fully developed laminar flow, V average is half the maximum velocity. So for a fully developed laminar flow, what will happen? V average is half. So the 50% that is 1 rupee. So like this, we can see the velocity of flow whenever it is fully laminar flow pipe. So fully laminar flow liquid or a fully laminar flow fluid, right? Next, the classification of fluid gravity flows. So whenever you are using the gravity without uh, without keeping aside the pump, the pressure electromechanical devices. So whenever you are using gravity means for using of fluids entry or exit, we are having two types of classifications. One is a Reynolds number, other one is a Froude number. We are using flow Reynolds number RERR. Second one is flow Froude number capital F. So these are the two scientists have gave some explanation regarding the fluid flow in gravity. In gravity ante we are not using any mechanical devices like pump or fans, etc. So they have derived some of the experiments based upon this Reynolds number and also the Froude's number. Now, if you see some sort of liquid or a fluid is passing from upper tank to the lower medium. Now, see, this is a container. This is a container. This is a container where you are having a hooper at the top side. You are pouring some dye. Dye means some pigment. For example, dye means for our garments, battalki. Garments means nothing but our cloths. So we are getting cotton is white in color. So but our cloths, our garments, or everyone is colors. So what is the thing you are adding? We are adding some pigment, nothing but a dye. Chemical dyes add chestam kabatti our clothing will be of different colors and shapes. So generally the cotton is in white color. Cotton to manaki silk, whatever the material we are getting, it generally will be in white color. So if you want to make colors ivvalankondi, shirts ki, fans ki, trousers ki. So we are adding some dye. So that is nothing but an example we are taking is the dye. So the Reynolds experiments involved injecting a dye streak into the fluid moving at constant velocity through the transparent tube. Now, if this is the diameter of the pipe, so there is a container, there is a hooper where the dye is passing into the section and it is moving through the aperture diameter D. So with this transparent thing, we can say give some explanation about the Reynolds number respective to the laminar flow and turbulent flow. The fluid type, tube diameter and the velocity flow through the tube were varied. So ఇక్కడ మనకి వేరే అవడానికి ఏమేమి ఉన్నాయి? So the fluid type. So what is the fluid type? Dyes lo we are having what type of fluid type? High viscosity, low viscosity, high surface tension, low surface tension. So properties based చేసుకొని మనం fluid category చేసుకున్నాం. Next, the tube diameter and the velocity of flow. So this all gives the variation. Obviously gives the variation. Next. Now if you see, if you cross section, దీన్ని మనం exaggerate చేస్తే, exaggerate means దీన్ని మనం పెద్దదిగా చేసి, we are seeing now how the flow is moving. When the dye means the liquid. the dye followed a straight path. So whenever the discharge, low discharge lo manam pampistunnappudu, the fluid whenever it is going in low discharge, so the fluid is moving in a straight direction. See, the arrows are moving in a straight uniform direction. That is, the dye is following a straight path. Second one, the dye is followed by the wavy path with a streak intact. So whenever the discharge is high, whenever the velocity is high, right, exaggerate cheste, the pink color lo unnadi, this is a diameter anukunte, the pink color lo unnadi, this one is moving in a zigzag movement, is moving in a wavy motion. There is nothing but the dye is following the path, streak intact. Next one, dye rapidly mixed through the fluid in the tube. So ఇది మనకి fluid అనుకోండి generally. So the blue color, the container is here. Container lo we are having some liquid, some water based, think it is a water is filled in a container. So in this water, a dye which is not mixed with water, so we are pouring through the hooper, through the diameter pipe. So whenever it is flowing with a constant velocity, water ni disturb cheyakunda ee liquid anedi straight fashion lo veltundi. Whenever you are having a medium discharge, then what happens to this dye anedi wavy motion lo it is moving in the liquid. Whenever you are having a high discharge, dye is rapidly mixed through the fluid in the tube. So whenever you are having a high discharge, appudu em jarigindi, in the pipe, the dye is mixing with the water, and it is making some whirlings and going inside the diameter of the pipe and coming outside. So మనకి ఈ 3 changes low discharge లో ఏం జరుగుతుంది, medium discharge లో ఏం జరుగుతుంది, high discharge లో what happens, that is shown in this figure. Now the Reynolds classified the flow type according to the motion of the fluid. So this Reynolds scientist, the motion of the fluid ni base cheskoni, he has classified the flow type. Now see here, ఎప్పుడైతే the fluid, ఎప్పుడైతే water లో ఎప్పుడైతే the fluid is flowing in a straight fashion without disturbing any direction, its direction, the flow is in a straight line with a low discharge, it is nothing but the laminar flow. Every fluid molecule followed a straight path that was parallel to the boundaries of the tube. So ఇది మనకి ట్యూబ్ అనుకుంటే, బౌండరీ లేయర్ ట్యూబ్ అనుకుంటే, సో boundary surface ki prati molecule of the dye, that is whatever the dye you are experimented, that is following a straight line path, then that is nothing but a laminar flow. Understood? Next, second one, whenever you are applying the medium discharge with some velocity, increasing the velocity in the pipe, in the dye pipe, then this is nothing but transitional flow antunnam. Edaithe wavy nature go, the molecules are going in a wavy nature, we are calling them as a transition flow. What happens here, every fluid, this is nothing but transition flow. Every fluid molecule followed wavy but parallel path that was not parallel to the boundaries of the tube. Here the dye is in wavy motion lo unnadi, at the same time these are parallel, the wavy but parallel path that was not parallel. So ఇది చూడడానికి parallel path లాగానే ఉంది, అంటే ఈ వేవ్ కి ఇది parallel, right? సో ఇది కింద ఉంది, ఇది కూడా కింద ఉంది, right? ఇది పైకి వచ్చింది, ఇది కూడా పైకి వచ్చింది, మళ్ళీ ఇది పైకి వచ్చింది, ఇది కింద. సో these are making parallel to with respect to each other, but these are not parallel to the boundary, pipe boundary. There is nothing but transition flow. Third one, high discharge తో ఎప్పుడైతే the fluid is flowing in the pipe, water pipe, then this is nothing but the turbulent flow. So every fluid molecule followed a very complex path that leads to the mixing of the dye. అప్పుడు ఏం జరుగుతుంది, డిస్టర్బ్ చేసిన తర్వాత హై డిశ్చార్జ్ తో, హై వెలాసిటీతో whenever the fluid is going in the pipe, then these are taking different movements. We don't know what is the direction is going. సో ఇందాక మనం చూసిన దీంట్లో ఈ మూమెంట్ ద్వారా ఇట్లా మనకు whirlings వచ్చి it is taking different directions and going from the pipe to the exit. Then that type of flow we are calling them as turbulent flow. So ఈ విధంగా Reynolds అనే పర్సన్ has made an experiment in a వాటర్ కంటైనర్ తీసుకొని దాని లోపల ఒక డై, ఏదైతే వాటర్ కి ఈజీగా మిక్సింగ్ కానీ డై తీసుకొని he has done an experiment and named it as ఎప్పుడైతే the water is going, the dye is going in a straight line parallel to the boundaries, we are calling them as a laminar flow. Whenever the whenever the dye is going in a zigzag way, wavy nature, we are calling them as a transition flow. Whenever the flow with a high discharge is flowing in different directions, different rotational different directions, we are calling them as a turbulent flow. So అర్థమైంది కదా, what is a laminar, transitional and turbulent flows. Next, Reynolds found that conditions for each flow types depends on 4 factors. So ఎప్పుడైతే ఈ ఫ్లోస్ మనము డిఫరెన్షియేట్ చేసామో, we are having some sort of conditions. Depends on what? First one is the velocity of the flow. Flow యొక్క velocity. ఓకేనా, the velocity of the flow. Flow velocity ఎలా ఉంది is considered with u. The second one is the diameter of the tube. Second parameter ఏంటి? The diameter of the tube, d. Third one is the density of the fluid, the సాంద్రత అంటాం. Density means సాంద్రత. How much density is there for the fluid? That is termed as rho. Fourth one, the fluid's dynamic viscosity. The fluid's dynamic viscosity, mu. So these are the 4 factors, conditions, depends whenever you are using these types of things. What is the first one? Velocity of the flow. The first one is the velocity of the flow. It is noted with the u. వేరే బుక్స్ లో మీకు వేరే సింబల్ ఉంటుంది. ఇక్కడ కొన్ని బుక్స్ లో రైనల్డ్స్ నెంబర్ అంటే క్యాపిటల్ ఆర్ అని చెప్తాము, కొన్ని బుక్స్ లో ఆర్ స్మాల్ ఈ అని చెప్తాం. సో both I will discuss with you. The first one is what is the condition? Velocity of the flow. The second condition is the diameter of the tube. The third condition is the density of the fluid. The fourth condition is the fluid's dynamic viscosity. Okay na? Yes. He combined all these variables into a dimensionless combination known to as flow Reynolds number. So కొన్ని books లో R ఉంది, కొన్ని books లో RE ఉంది. Don't get confused. R అన్న RE అన్న సేమ్. సో ఏం చేశారు, మనము యూనిట్ 1 లో డైమెన్షన్స్ యూనిట్స్ గురించి చెప్పుకున్నాం. సో ఈ నాలుగు కంబైన్ చేసుకొని he made some Reynolds flow number అనేది he has given. Then what is RE here? It is defined as rho into u into d divided by mu. This is a formula derived by the Reynolds. Okay. Yes. The flow Reynolds number is often expressed in terms of fluid kinematic viscosity. Lowercase Greek letter mu. You are calling them as a mu. Where v is equals to mu by p. Units వచ్చేంటి meter square by second. Next, rearranging them, mu is equals to rho into v. So substituting into r లో సబ్స్టిట్యూట్ చేస్తే mu వాల్యూ ని, సో mu వాల్యూ ఇక్కడ ఉంది కదా, mu వాల్యూ ని r లో సబ్స్టిట్యూట్ ఈ r ఫార్ములాతో సబ్స్టిట్యూట్ చేస్తే r is equals to mu into u into d divided by mu into p. నెక్స్ట్ ఏమవుతుంది, ఆటోమేటిక్ గా this 2 will get cancelled. రెండు క్యాన్సిల్ అయిన తర్వాత the formula is r is equals to mu into d divided by v. Next one, the value of r determined the type of the flow in the experimental tubes. So whenever we have found out the r, so we have to write some number. Experimental, whenever you have seen through the experiment, so we are having some sort of numbering, so some range. So beyond this one there is one type of flow, beyond this one there is one type of flow, below this one this is one type of flow. Like this you are having some sort of numbers. So what are this? Just so laminar flow low, the r should be less than 1000. R should be less than 1000. So whereas in the transition flow, the r should be in between 1000 to 2000 number. That is the standard derived by the experiments. Coming to the turbulent flow, the r should be greater than 2000. So ఇది ఒక బుక్ లో ఇలా ఇస్తే ఇంకొక బుక్ లో వేరేలాగా. సో the basic thing is the laminar flow అనేది less than 1000 లో ఉండాలి, రైట్. ట్రాన్సిషన్ ఫ్లో అనేది 1000 to 2000 మధ్యలో ఉండాలి, అండ్ ద టర్బులెంట్ ఫ్లో వచ్చేసి మోర్ దెన్ 2000 లో ఉండాలి, రైట్, విత్ రెస్పెక్ట్ టు r is equals to ud into v. సో ఇందాక మనం చెప్పుకున్న ఎక్స్పెరిమెంట్ ఇందాక మనం చెప్పుకున్న ఎక్స్పెరిమెంట్, whenever it is shown the reality, so real గా ఈ పైప్ లో నుంచి రియల్ గా whenever the fluid is passing from this small orifice into the glass tube like this shown. Now see the laminar flow, how the fluid is flowing very cleanly without any jerk, without any, see the green color, see here, convertible, but you have to see the line is passing very clearly. Whenever it is transitional, ఆల్రెడీ ఈ పైప్ లోపల వాటర్ ఉంది, సో మీకు చేంజెస్ కోసం ఇక్కడ వైట్ పేపర్ లాంటిది అటు సైడ్ అడ్డం పెట్టి, గ్లాస్ దానికి అడ్డం పెట్టి చూపిస్తున్నారు. సో హియర్ ఇఫ్ యూ సీ ద గ్రీన్ కలర్ ఈస్ హ్యావింగ్ సమ్ వేవీ నేచర్, అప్ అండ్ డౌన్ zigzag వేవీ నేచర్ అండ్ ఫ్లోయింగ్, దట్ ఈస్ ట్రాన్సిషనల్. whenever it is flowing in the turbulent, ఆల్రెడీ మొత్తం వాటర్ మిక్స్ అయిపోయింది, so it is mixed in the water and it is going in a zigzag way, that is turbulent flow. Turbulent flow. I think hope you understood this concept. Laminar flow ante enti, turbulent enti, ఇప్పుడు మీకు ఐడియా వచ్చింది కదా, రైట్? yes. okay, the transition from the laminar to turbulent flow, the transition is for transformation, the transition from laminar to turbulent flow depends on what? Depends upon the geometry of the tube, surface roughness, flow velocity, surface temperature, and the type of fluid. The flow regime depends mainly on the ratio of inertia forces to the viscous force. Therefore, the Reynolds number can be written as Reynolds number RE is equals to inertia forces by viscous forces. What the inertia force? Inertia force is equals to V average into D by V. That is equals to rho into V average D by mu. Okay. At large Reynolds numbers, at large Reynolds number, the inertia forces which are proportional to the fluid density and the square of the fluid velocity are large relative to the viscous forces, and thus the viscous forces cannot prevent the random and rapid fluctuations of the fluid. That is nothing but large numbers ante enti turbulent lo untundi already. At small or moderate Reynolds number, the viscous forces are large enough to suppress these fluctuations and keep the fluid in line. In line and automatically it is a laminar flow. When the Reynolds number is very small, we are calling them as a laminar flow. When the Reynolds number is very large, we are calling them as a turbulent flow. Okay, next. The critical Reynolds number, RE critical. This Reynolds number at which the fluid becomes turbulent. The value of the critical Reynolds number is different for different geometries and the flow conditions. So depends upon the geometries, depends upon the flow conditions, the RE number will automatically differs. Now if you see, the Reynolds number can be viewed as a ratio of inertial forces to the viscous force acting on a fluid element. So if you see, the RE is equals to initial forces by viscous force, that is equals to rho into V square average into L square divided by viscous force mu into V average into L. That implies rho into V average L divided by mu. So cancelling those L square V average, that is equals to V average L divided by mu. So L ikkada diameter తీసుకున్నాడు, ఇక్కడ just a D is a diameter. So you can take anything, but only thing is what are the initial forces ratio to the viscous force. RE is equals to inertia forces divided by viscous forces, right? Now in this slide we will see whenever we are using different types of pipes, so what are the formulas, what are the things we are observing. Okay, now see, for the fluid flowing through non-circular pipes, the Reynolds number is based on hydraulic diameter. So whenever it is flowing in a circular pipes, we are going in a normal process. Whenever the fluid is not going in a circular pipe, then Reynolds number is based upon what? Hydraulic diameter. Then what is the hydraulic diameter here? DH is equals to 4 into A divided by P. 4 into A divided by P. The hydraulic diameter DH is equals to 4 into AC by P is defined as it reduces to the ordinary diameter for the circular tube. Then the circular tube, children, a circular tube with the diameter D. What is the DH? The hydraulic diameter. Hydraulic diameter DH is equals to 4 into pi d square by 4 divided by pi d. That is equals to D. So D అనేది ఈ విధంగా మనము DH we have to find out. For a square duct, for a square closed duct, దీని ఏరియా L length into breadth A into A తీసుకుంటే, then what is the formula here? DH is equals to 4A square by 4A, that is equals to A, that is equals to A. Next, rectangular duct A into B. DH is equals to 4 into A into B divided by 2 of A into A plus B. That is equals to 2AB by A plus B. Next, the channel, open channel ఇలా ఉందనుకుందాం. Rectangular open channel A into B. That is also 2H is equals to 4AB of 2A plus B, 2A plus. So these are the 4 cross sections where you are using a Reynolds number with the hydraulic diameter whenever you are getting the problems. So if you see what is the laminar flow? Less than 2300 degree. So in some books or some things you can find out some standard things, the value is like this. Transition flow 10,000 less than, greater than 10,000. But the same case, if you see the dye is injected here. So what happens to the dye trace? So here whenever the velocity is an average condition in this pipe, so this is a laminar flow. Laminar flow tarvata you are getting the turbulent flow. Totally disturbing the water. That is nothing but the turbulent flow. In the transition flow region, of 2300 less than RE, less than 10,000, the flow switches between the laminar and turbulent flow seeming randomly, right? So these are the various types of flows you are seeing in the experiment whenever you are conducting a Reynolds experiment. Okay. Now if you see in the gaseous form, how the laminar and turbulent flow acts. So the other example in the gaseous form, see this. So this is experiment done on the gas. This is experiment done with the how the laminar and turbulent flow occurs in a gaseous state. Okay, here you are having a candle, lighten the candle. So whenever the candle is lightening, so the fumes or the gas escapes from the wire, this fire. So whenever these gases are escaping into the atmosphere, see the movement of the gas, how it is flowing. So the gas coming, like the fumes coming from the fire at the starting point, these are in a straight line path. మీరు చూసే ఉంటారు. So observe me, కాంట్ మీరు రేపు ఇప్పుడైనా అబ్జర్వ్ చేయండి. Whenever the current goes in your house, switch on the candle light చేసుకొని, now see the fumes, how they are passing. So starting వచ్చినప్పుడు straight గా వస్తుంది. Whenever it is going beyond this fire, what happens beyond this flame? What happens? It is moving in a wavy nature and finally going to the turbulent process. So what it is saying here, the laminar flow is encountered when the high viscous fluids such as oils flow in a small pipes or narrow passages. So narrow passages flow, right? Small pipe diameter flow whenever the oil is flowing. So we will consider generally it is in a laminar flow. Next, the laminar is a smooth streamlines and highly ordered motion. So laminar ante ela cheptunnam, we are defining them as these are the smooth streamlines and highly ordered motion. Next, turbulent flow. Turbulent flow ఎలా చెప్తున్నాము? The turbulent flow or the velocity fluctuations. ఇక్కడ velocity fluctuate అయింది కదా, ఇక్కడ తగ్గింది, ఇక్కడ పెరిగింది, మళ్ళీ ఇక్కడ తగ్గింది, ఇక్కడ పెరిగింది. So like this, you are having the velocity fluctuations and highly disordered motion. Next one is the flow fluctuations between the laminar and turbulent flows. So the laminar flow ki, turbulent flow ki మధ్యలో ఎప్పుడైతే ట్రాన్స్ఫర్మేషన్ జరుగుతుందో దట్ థింగ్ we are calling them as a transition flow. Most flows encountered in the practice are turbulent. So theoretically గా మనం ఒకటి చెప్పుకుంటే practically we can say that most of the flows which are encountered in the real time practice are turbulent, right? Next, the laminar and turbulent flows regimes of candle smoke. So మనకి ఎగ్జాంపుల్ ఈ విధంగా చూపిస్తున్నారు గ్యాసెస్ లో ఫామ్ లో ఉన్నప్పుడు. The behavior of colored fluid injected in the flow in laminar and turbulent pipes in the fluid. So the same thing what you have seen in the last this 5 case example. Here also we are passing some amount of dye injected into the water. So whenever it is flowing in a straight line with a small narrow pipe, the small pipes, narrow passages, it is flowing in a straight line. So whenever this pipe, whenever you are having a high discharge of fluid, dye injection is with a high pressure, so it is passing and it is making some changes in the liquid. ఇలాంటివి మీరు ఆల్రెడీ మూవీస్లోనో లేదంటే ఏదో ఒక ఎక్స్పెరిమెంట్లోనో యూ హ్యావ్ డన్ ఇట్, రైట్ ఆర్ రాంగ్? ఫర్ ఎగ్జాంపుల్ ఇఫ్ యు టేక్ ఏ గ్లాస్, ఒక ట్రాన్స్పరెంట్ గ్లాస్, ఒక ఆబ్జెక్ట్, ఒక కంటైనర్ తీసుకొని ఫిల్ ద వాటర్ ఇన్ దట్ అండ్ ఒక కోకోనట్ ఆయిల్ లోపల కొంచెం కలర్, యువర్ హోలీ కలర్, ఏదో ఒకటి కలర్ యాడ్ చేసేసి, రెడ్ కలర్ ఆర్ వాట్ ఎవర్ ద కలర్. సో మిక్స్ ఇట్ థరోలీ అండ్ టేక్ దిస్ ఆయిల్ లిక్విడ్ అండ్ pour in the any ఇంజెక్షన్. మనకి సిరంజెస్ ఉంటాయి కదా, సిరంజ్లో పోసుకోండి. దెన్ వాటర్ స్టిల్గా ఉన్నప్పుడు ఇంజెక్ట్ దిస్ విత్ నీడిల్ ఇన్ టు ద వాటర్. స్లోగా ఇంజెక్ట్ చేయండి లేదంటే ఫాస్ట్గా ఇంజెక్ట్ చేయండి. యూ కెన్ సీ ది డిఫరెన్సెస్ బై కండక్టింగ్ ద ఎక్స్పెరిమెంట్. సో విత్ దిస్ విల్ స్టాప్ ద క్లాస్. I think the time is very short. So only Riyaz, Sandeep and Shravani were present in the class. So take a screenshot. So I'm also taking a screenshot. So after this class, I will upload this video in the YouTube, and before yesterday's class also I will upload in the YouTube. They're self-explanatory. So the two links will be added in your WhatsApp group. Open it, view it, and share to the students, those who are not in the class.